All right, let's dive into one of the most fascinating, most mind-blowing topics in all of science, black holes. They really are the ultimate cosmic mystery. And today, we're going to break down what they are, how they're born, and why they just might hold the secrets to the entire universe. So just start with this thought experiment. What if there was a place in space with a gravitational pull so intense, so powerful, that once you cross a certain line, there's just no coming back? Not just hard to escape, I mean literally impossible. This isn't some sci-fi movie plot. Nope. This is the reality of a black hole. And that's really the heart of it. A black hole is a spot in space-time where gravity has become so strong that nothing gets out. To escape, you'd have to go faster than the speed of light, which is the universe's ultimate speed limit. And since nothing can go faster than light, well, you get the picture. Nothing escapes. You know, this incredible idea didn't just pop out of nowhere. It actually came from the mind of Albert Einstein himself. Way before we had any technology that could even hope to see one, his general theory of relativity predicted it. He realized that if you could just cram enough stuff into a tiny enough space, gravity would take over completely, warping the very fabric of reality, space-time, into what we now know as a black hole. So, how does the universe actually cook one of these things up? Well, the process is about as dramatic as you can imagine, and it all starts with the death of a really big star. Let's walk through it. First, you have a massive star, way bigger than our sun, just burning through its fuel for millions of years. But when that fuel runs out, the outward push from all that nuclear fusion just stops, and gravity takes over. The star collapses in on itself and then explodes in this unbelievably bright flash called a supernova. But for the biggest stars, that's not the end. The core that's left over just keeps collapsing and collapsing, crushed by its own gravity into a point of infinite density. And bam, a black hole is born. Now, here's something important to know. Not all black holes are the same size. That process we just talked about creates one kind, but there's a whole other category of these things out there, and they are much bigger. So on one side, you have your stellar black holes, born from a single dying star. But on the other side, you've got the real monsters of the cosmos, supermassive black holes. We're talking millions, sometimes billions of times the mass of our sun. We now know that these giants are sitting right at the heart of most big galaxies, acting like a gravitational anchor. In fact, our very own Milky Way has one. Its name is Sagittarius A star. Okay, this is where things get really strange. As you get close to a black hole, our whole understanding of how reality works starts to fall apart. The laws of physics just break down right at the edge, at a boundary that we call the event horizon. And this leads to one of the wildest concepts in all of physics. It's called spaghettification. I know, it sounds kind of funny, but trust me, what it describes is terrifyingly real. So, what in the world is it? Just like Einstein predicted, a black hole's gravity is so powerful it actually bends space and time. In fact, time itself literally slows down the closer you get. But spaghettification is on another level. The pull of gravity on the part of an object closer to the black hole is so much stronger than the pull on the part that's farther away, that it gets stretched, it gets pulled apart, like a piece of spaghetti, into a long, thin noodle of atoms. It's a bizarre fate, but it's totally real science. Now, for decades, all of this was just theory. I mean, brilliant, mind-bending theory, but still, it was all on paper. And then, in 2019, everything changed. Scientists used a network of telescopes all across the globe, working together as one giant eye, and they did the impossible. They took the first ever picture of a black hole shadow. The theory became real. You could see it. It was just a monumental moment for all of science. So this brings us to the big question. Why are we so obsessed with these things? I mean, beyond just how weird they are. Well, it turns out black holes are like the universe's ultimate laboratory. They're the key to unlocking some of the deepest questions we have. See, these cosmic giants push physics to the absolute brink. By studying them, we might figure out what happens when you crush matter down to an infinite point, a singularity. Could they be gateways or wormholes to other parts of the universe? What about time itself? The way they slow time down forces us to question everything we know about it. Some scientists even think the conditions inside a black hole are a lot like the first moments of the Big Bang, which could give us a peek into how everything began. From an abstract idea in Einstein's head to an actual image on a screen, black holes really represent the frontier of what we know. It seems like every time we make a discovery, we just unlock a dozen more questions. They're this powerful reminder that no matter how much we figure out, the universe is still packed with mysteries just waiting for us. Which leaves you wondering, what other secrets are hiding out there in the dark? All right, get ready for a trip. We are about to dive into some of the most, mind-bending truths about our universe. We're going to cover everything from the strange sounds of deep space to a scale so massive it's almost impossible to wrap your head around. Honestly, these are the kinds of facts that really remind you just how much is still out there waiting to be discovered. So let's start with a question. I want you to really picture it. The vast, dark emptiness between the stars and planets. What do you actually hear in your mind? Yeah, for most of us, the answer is complete and total silence, right? It's a vacuum. We all learned in school that there's no air for sound to travel through, and, that's what we've always been told. But what if I told you that's not quite the whole story? See, it turns out we can listen to space. We just can't do it with our ears. Spacecraft, like the legendary Voyager 1, have special instruments on board that can detect something called plasma waves. These are just vibrations in the charged gas that fills space. And here's the cool part. Scientists can take those vibrations and convert them into audio we can hear. It creates these incredibly eerie, almost spooky sounds. So no, it's not sound in the way we think of it, but it really is the voice of the cosmos. So, space isn't totally silent after all. And the very machines that taught us that, they're just the beginning of the story. So let's shift gears and talk about the incredible robotic explorers we've sent out to actually see things up close, starting right here in our own neighborhood. I mean, think about it. You've probably seen those amazing selfies from the Mars rovers, right? Like from Curiosity or Perseverance. But have you ever actually stopped and thought, wait, how does a robot, all by itself, millions of miles away, even do that? It's definitely not as simple as just holding out a phone and clicking a button. What the rover does is extend its long robotic arm, and the camera on the end takes dozens, sometimes hundreds, of individual pictures. Then, all those separate images get sent back here to Earth, where engineers painstakingly stitch them all together to create that one perfect, seamless portrait. It's really less of a selfie and more like an epic cosmic photo shoot. Of course, before a rover can take any pictures, we have to get it there in the first place. And trying to send a heavy machine across the solar system is, not easy. It takes an unbelievable amount of speed and some seriously clever thinking. So, to save a ton of fuel and a ton of time, engineers use this brilliant trick called a gravity assist. The best way to think about it is like a cosmic slingshot. You aim the spacecraft to fly really close to a huge planet, like Jupiter, and you use that planet's massive gravity to just whip the spacecraft around it. It gets this incredible speed boost and a new direction, all without burning any extra fuel. It's just a masterpiece of physics. And the absolute best example of this has to be Voyager 2's Grand Tour. It took advantage of this super rare planetary alignment that only happens once every 175 years. It used Jupiter's gravity to get to Saturn, then it used Saturn's gravity to get to Uranus, and then Uranus's gravity to get all the way out to Neptune. This kind of planetary hopscotch would have been totally impossible without the gravity assist. Just an amazing feat. And that amazing journey brings us to where the Voyager probes were headed all along. Because after they toured the planets, they didn't stop. They just kept on going, heading straight out into the great dark unknown, way beyond the influence of our sun. And this is a truly incredible moment for all of us. Back in 2012, Voyager 1 officially left our solar system. It crossed the boundary and entered interstellar space, that vast emptiness between the stars. It is, right now, the farthest thing from home we have ever created. Just try for a second to imagine that distance. Over 20 billion kilometers. A number that big is, it's almost meaningless, isn't it? So let's try to put it in a way that makes a little more sense. If Voyager 1 sent us a signal right now, even with that signal traveling at the speed of light, it would take more than 20 hours to get here. Think about that. A single radio message travels for nearly a full day just across the distance from that tiny probe back to us. And as it sails silently through that cosmic ocean, Voyager is carrying something special. The team who built it had the perfect way to describe its precious cargo. That message in a bottle is the golden record. It's basically a time capsule for our planet. On it, there are sounds of Earth, like wind and rain and whale songs. There's music from all over the world, and there are greetings spoken in 55 different languages. It's a snapshot of humanity, sent out into the void on the off chance that someday, somewhere, someone else might find it. So Voyager's journey into the space between stars is just monumental. But to really, truly get what that means, we need to zoom out. I mean, all the way out, and put everything we've talked about into its proper, grand, cosmic context. I want you to try and imagine every single grain of sand on planet Earth. All the beaches, all the deserts, every last one. It's a number so big you can't even really picture it. And yet, astronomers are pretty much certain there are more stars in the universe than that. Way more. Okay, so how on earth could we possibly know that? Well, thanks to incredible instruments like the Hubble Space Telescope, we've been able to look deep into space and estimate that there are hundreds of billions of galaxies out there. And each one of those galaxies has billions of its own stars. You do the math, and the conclusion is just staggering. You know, when you think about it all, from hearing the strange hum of plasma waves, to getting a selfie from Mars, to sending a message in a bottle out towards other stars, it all points to one incredible truth. For all of our amazing achievements, we are just getting started. And that just leaves you with this one final, humbling question. In this unbelievably huge universe, with so much we don't know, what do we point our telescopes at next? What mysteries are just waiting for us to find them?